Hello everyone, this is Robotics and Automation course. Our topic for today is Spatial Descriptions Transformation. I'm going to give sample problems related for this topic. So example 1, given a diagram which shows to find the rotation matrix value for this example. So I'm going to show you how to determine the rotation matrix. So here, the problem is asking for the R, B to A, that is B of frame B relative to A or relative to frame A. Now, let us prove this one, how this is obtained, this one. So that is equal to the matrix. If you recall that for the first column, that is the rotation at X, that is XB to A. So this will be XB. This is also XB. And this is XB. That products relative to the reference frame, this is XA. That YA and ZA for the first column. For the YB to A, so this is YB, 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 dot relative to the frame A. So this is XA dot YA dot ZA. And on the third column, this is the ZB to A. So this is ZB, ZB, ZB relative to frame A. So this is XA dot YA dot ZA. Now, since this is all dot products, to recall that note that dot products of two vectors. So this is, for example, vector A, and this is vector B, theta. So this is to get the dot product of that A dot B is equal to the magnitude of A, the magnitude of B, cosine of the angle theta, or the included angle theta. So this is the dot product definition. So to determine XB dot A, so we have to look at the XB and A. So what is the dot product of XB dot A? Since both vectors or these are unit vectors directed on the same directions, so that will be 0 degrees. So cosine 0 will be 1. And XB dot A, so this is your XB. Where is the XB? That XA, yeah, that is done. Now XB dot YA, so this is your XB and this is your YA, is 90 degrees. So all all vectors with the included angle 90, it will be 0. So this is 0. And this is 0 also. Why? Because xb dot za is, this is the xb and this is the za, so it's 90 degrees, so it's 0. Next, for the second column, we go to the yb, so this is the yb dot xa. yb dot xa is 90 degrees, so this is 0. yb dot ya, where is the ya? And yb dot ya, 90 again, so this is 0. And yb.za, so where is the yb.za? Same direction. So cosine 90 is cosine 0, that will be 1. So that's the result. And then on the third column, the remaining values. So we have here the zb.xa, zb.xa. So this is the zb, and here is the xa, it's 90. So this will be 0. It's 90 degrees. And then for the zb.ya, if you look at it, this is zb and this is ya. It's completely opposite to each other. It is 180 degrees. So what is cosine of 180? That will be -1. Okay, and then for the zb.za, so this is the zb and this is the za. It's 90 degrees. So the value will be 0. So as you can see, this is the proof of this answer here. So this is the answer. The rotation matrix of this B to A. Actually, this can be verified. This can be verified by the formula. This is solution 2. This is solution 1. For solution 2, this can be verified that the frame B is rotated. Frame B is rotated. Frame B is rotated. If you look at it, the direction of rotation, so it will be with the x-axis, is rotated about x-axis. At what angle? At an angle of 90 degrees, as you can see it. Why? So the original position of frame, this is the frame A, the blue colored frames, and the frame B was originally in this position. Since this is rotated, so the new position of frame B is, the ZB is becoming opposite to YA because of the rotation at 90 degrees. Now we can prove that one using the formula, using the rotation matrix about y-axis. So R, which is x-axis, the angle alpha. So this can be proven, and the formula of this in matrix will be for the R, a rotation of x at an angle alpha. So you have here 1, 0, 0, and this is 0. Cosine of the alpha, which is 90 degrees. And this is sine of 90 degrees. This is 0. Minus sine of 90 degrees. That is minus 90. And this is cosine of 90 degrees. This can be verified with this second solution. So look at carefully. we have here what is cosine 90? Rewrite this one again, 1, 0, 0. This is 0. What is cosine 90? Cosine 90, as you can remember, it gives you 0. But what is sine 90? That gives you 1. And then here, this is 0. And what is sine of the 90? Is 1. Since it's negative, you get negative 1. And for cosine 90, this is 0. So as you can see, they are the same. Okay, now let's proceed. Let's proceed with the example 2. Another example. The question here is find the final position. And we will prove this answer. This is the solution. So what will be the solution for this? So I'm going to show the solution. In this problem, by the way, the given values are, this is a rigid body configuration. We have the frame A and we have the frame B, which is translated. And then the position is given, which is the 031 and 011. This coordinate is the origin of the frame B, this coordinate. So this is our, in vector terms, this is between origin 0, origin A and origin B. This is the projected vector. So this is what we call the PBORG to A. And this coordinate is the coordinate of the point P in question with respect to frame B. So this is the coordinate of that. And then this frame B, if you can see, it is rotated about what? 90 degrees with respect to x-axis. Why? Because the original position of ZB was here before rotation, and your YB should be here before. So this is now the result of, this is now the rotation of the frame B. Now the question is, what is the final position, that is the point B in question with respect to the frame A? So to calculate that one, we have two solutions for that. The first solution is using the using 3x3 homogeneous transformation. So what is that? From the triangle, this one is our vector P origin with respect to A. This one is our P to B, the vector of the point P in question with respect to frame B. And we are looking for this one, which is the final position with respect to A. So the relationship or the equation for that will be P to A, the final position can be determined by adding the two vectors PBORG times this with a rotation. So we have here the PBORG, or you can start with P to B. You can start with the rotation B to A. multiply that with the P2B. So this is the vector of this, which is undergone rotation, and the PBORG to A. This one is responsible for the translate or translation, and this one is responsible for rotation, rotate. This is also known as prismatic. Prismatic. This is also known as revolute. Okay, so with that, we can be able to solve. So solving for the P2A is equal to here the rotation, by the way. So this is the rotation. The rotation B2A, if you can see it, it's about the x-axis. It's about x-axis y, because the original position of YB was here at no rotation, and your ZB was here. So the rotation is about y-axis. So this would be y with the angle alpha. So for y, it's not alpha, it should be phi. Sorry, this is not y-axis, correction. X-axis. X, correction. So the rotation is about x-axis. So that will be x. And the angle will be theta, alpha for the x-axis. This will be alpha, which is multiplied by P to B plus our PBORG, this one, to A. Now substitute, this is equal to the matrix of Rx alpha, that will be 1, 0, 0, 0, and alpha is 90, because you can see in the graph, it's rotated 90 from here to here, it's 90. So cosine 90, sine 90, and this is this is 0 minus sine 90, cosine 90. Multiply that with the P to B. The P to B is the coordinates given, that is 0, 1, 1 plus the PB ORG to A. So this is the coordinates of that, which is 0, 3, 1. Now simplify that one. We have here 1, 0, 0. This is 0, 0. Cosine 90. This is 0. This is 0, by the way. This is 0. Cosine 90 is 0. Sine 90 is 1. This is 0. Sine 90 is 1, negative 1. And this is 0. Multiply that with 0, 1, 1. Okay. Plus 0, 3, 1. Okay. Now we got this is equal to, multiply first these two matrix. So 1 times 0 is 1 times 0 is 0. 1 times 0 is 1. Plus, 1 times 0 is 0. 1 times 0 is 0. So that's what you will simplify that one. How about for the second row? 0 times 0 is 0. 1 times 0 is 0. 1 times negative 1, minus 1. And finally, 0 times 0 is 0. 1 times 1 is 1. Then 1 times 0 is 0. That's the result. Then you add with that, with the 0, 3, 1. Simplify this one. So you have here 0, negative 1, and 1. Plus 0, 3, 1. Therefore, our final answer here is P2A. The final position, therefore, is equal to 0 plus 0 is 0. Negative 1 plus 3 is 2. 1 plus 1 is 2. This is the answer. So this is the answer for the problem asked which is the final position. Or you may write like this, or P2A is equal to 0, 2, 2 transpose relative to the frame A. So that's how to write the answer. Now, here is the solution 1 using the 3 by 3 homogeneous transformation. Then let's go to the solution 2. Solution 2. For the solution 2, what are we going to use? Using 4 by 4 homogeneous transformation, or HT. I will write HT. So we have here given the positions. I will write the positions. For the P to B, it was 0, 1, 1. For the P, B, O, R, G to A is equal to 0, 3, 1. That is 0, 3, 1. This is 0, 3, 1. Now, the given orientation is R B to A, which is equal to R X about 90 degrees positive. From the diagram, it shows positive. So here, you can use the 4 by 4 homogeneous transformation. So the equation will be P to A. So finding for the P to A. So you will use this equation P to A is equal to the T, B to A, multiply that by P to B. So that's what that's what the formula for the 4 by 4. So expand this one. Our P to A over 1. So we expand into 4 by 1, and this one, what's the inside of the T? You have here the R 3 by 3 matrix, which is B with this from frame B to A with respect. Then here is our PB ORG. The translate, this is rotate and translate, and insert 3 variables 0, 0, 0, and 1. This is the 4 by 4, and multiply that with P to B, which is 4 by 1. So this is P to B over 1. Continue. Substitute that one, or I will do it here. Continue with the P to A. So I will continue from here. Our 3 by 3, this is a rotation, which is the Rx, Rx 90 degrees. Therefore, I will write the matrix for that, which is 0. I mean, the matrix for that is 1. Where is that? Rx 90. So this is the matrix 1, 0, 0 for the Rx 90. 1, 0, 0, 0, 1, 0, 0, 1, 0, minus 1, and 0. So we will bring it here. That will be 1, 0, 0. This is 0, 0, 1. And this is 0, minus 1. And this is 0. That is the Rx 90 degrees. Okay. Then the inserted 3 zeros to compensate the 4 by 4, it will be here. And our PBORG is 0, 3, 1, and this is 1. That's the one. Multiply that with P to B, 0, 1, 1. Insert. This is the to become 4 by 1. We inserted that one. Then continue here. Continue. Let's multiply 0. Let's continue here. P to A is equal to, no. P to A over 1 is equal to multiply 0 times 1 will be 0. 1 times 0 is plus 0. 1 times 0 is 0. 1 times 0 again is 0. That's how to multiply. Next, the second row, 0 times 0 is 0. And then 1 times 0 is 0. 1 times negative 1 is minus 1. 1 times 3 is plus 3. Next, for the third row, this one to the third row, 0 times 0 is 0. 1 times 1 is 1. 1 times 0 is 0. 1 times 1 is 1. Then lastly, this one to this, all 0. 0 plus 0 plus 0. And we have left 1 times 1, that is 1. So the final answer, P to A over 1 is equal to, that's 0. This is positive 2, this is 2, and this is 1. That's the answer using 4 by 4. Finally, removing this one, the compensation values, P to A is actually equal to 0, 2, 2. So this is the answer for the P to A. The final position solved by using the 4 by 4. Or you may write this one, or P to A is equal to 0, 2, 2 transpose. So that's the solution for this problem number 2. Okay. Actually, when you are already familiarized about the orientation, you can easily get the values of the rotation matrix, like this example, based on the principle, this one, based on this principle. So that's it. These are the solutions for the two problems.